Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in the D programming language series. In this lesson, we're going to be looking at the auto keyword, but this time we're going to be looking at it as a return value from a function. Because auto, just like it can deduce the type when we create a new type, it can also deduce the type that we want to return from. Now, the trick is it's just got to be able to figure out if it's a legal conversion for whatever we're returning. So with that said, let me go ahead and show you with an example so you can understand exactly how this works. All right, so what I'm going to go ahead and do here is just create a simple function here. And let's just go ahead and call it something like get value. Just something nice and easy. And I'm going to go ahead and take in a parameter here. I'm just going to go ahead and call it the argument. And what I'll do is I'll say if arg is 1, then we'll return the value 1. Otherwise, we'll return the value 5.0. Okay, now let's go ahead and try to use this function. I'll just go ahead and put it in a right line here. And let's go ahead and use get value, passing in 1 on the first iteration, and passing in, well, any other value that isn't 1, like 0, for instance. Now let's go ahead and try to run this with our DMD. We'll run our main program. And, well, immediately we are getting some error here, because it's saying cannot implicitly convert expression 5.0 of type double to int. So that's saying that this 5.0 that we're returning, we can't just implicitly convert that or truncate it and assume that it's, supposed to be just 5. Because again, well, that might be a programming error, so D is pretty particular in how this works. Now we could fix this by trying to cast it, but the other trick that we could do if we really want this behavior or to sort of allow a promotion, meaning to treat this maybe between these two types of 5.0 and 1 as sort of the most conservative type as a double, we could go ahead and let the compiler do the work here by going ahead and saying, well, just figure out for me, is there a legal sort of conversion that we can do to make this compiler happy here? So if I go ahead and run it here, we'll go ahead and see now it compiles and prints out 1 and 5 respectively. And then what we're going to go ahead and do here just to verify this is let's just go ahead and print out the type ID here. So what is type ID doing? Well, again, type ID is just going to print out whatever the data type is of this return type. And we'll see that the compiler deduced that, well, double is what we can use here. Because, well, this is a double here that we're returning. And we could also treat this 1 as 1.0, for instance, and that would be legal. So that's really nice that we can do this. Again, auto is a very useful feature. I tend to use it for a lot of my functions, and it tends to make things a little bit easier, especially when you're writing generic code, when we get into templates, for example, in the D programming language. But with that said, let's go ahead and say that we have another problem here. Because, well, that's a pretty short lesson here, but what if we truly do want to return and delineate between 5.0 and 1? For that, we have something that's known as a variant that we could use. But I'll go ahead and wind back just a little bit here. So let me go ahead and open up a browser. And let's go ahead and bring you over to the Dlang homepage here. Let's go ahead to the language reference. And let's go ahead and just search for union. And we'll find structs and unions. So some of you might have come from other languages where you've seen unions, which can basically serve as different types here. Now let's go ahead and find our union here. And the basic idea is it's something that can hold multiple types in it. So unions can be handy if we want to hold any type and just sort of take the form as the largest type here. So I'll go ahead and scroll down to union here. And here's an example of using a union. So, and before I get too far into the unions here, what I want to go ahead and do is just show you something that's a little bit nicer than a union, and it's built into the standard library. So again, unions follow the same rules if you're coming from a C or a C++ background. But let's go ahead and look at some new data type here. And I've got to ahead and pull this up in another window. Let me go ahead and drag this in here. And it's called a variant. So this is another way that we can use a, again, discriminated union if you want to go ahead and see what that's used. Tagged union, or, well, some other different types. In fact, there's something called SumType that's going to be actually very useful, and we'll probably have a video on later. But let me go ahead and just show you a variant. Again, it's a type that can hold any type with, few restrictions here. And the idea is that you're able to, if you like, set this up to make sure that, well, there's sort of a safer way to set up the type, meaning that we can have VariantN. So let me go ahead and show you this here. And basically you can have allowed or unallowed types if you want. But I think we're getting a little bit too far from the point. I just want to go ahead and show you an example of variant here. So let's go ahead and use this. So what I'm going to go ahead and do is go ahead and just import standard variant. And now what I want to do is also import standard container. And we're going to just set up a variant for our return type here. So let's go ahead and create variant. And I'll just call this the result. And let's just go ahead and set up so that I can do the result equals 1 here. And let's go ahead and set up so the result equals 5.0. And I'm just going to return the result in both of these instances. Okay, now let's go ahead and we're still going to use auto here. And it should be able to deduce that the type is of variant here. So let's go ahead and run this. And now you'll go ahead and see, well, yeah, the type is variant. So that's what we're actually retrieving here now. But let's actually see what the underlying type is inside of here. And this, I think, will be kind of interesting. If you actually just do .type, and well, I can run this here. And this is basically .type is, since I'm returning a variant, which it's deduced here. Again, you can see the fully qualified name here. It should get me the underlying type of how this function call is returning the result in the first case and in the second case. So I'll go ahead and run this again, and you'll go ahead and see it looks like we're getting an integer and a double here. And let's go ahead and get rid of this type ID here. Let's see if it gives us something just a little bit cleaner. I'll go ahead and give this a try. I think it's worth printing out here. And now we can see int and double returned in each of these cases. And with the variant, again, we can try more wild things. For instance, if I wanted to, again, I put in the container here so that I can put in dlist of integer. And let's just go ahead and call it container, something like that. Let's just go ahead and set in our result, the container. And I'll go ahead and run our DMD here. And you can see in the first instance, I'm returning an integer. And in the second instance, I'm returning a list here. So if you want some sort of function that can return just anything in general, you can use something like a variant. You can use something like SumType, which I'll have to do a video, or if you want to see that video, make sure you comment below. Or in the general case, if you're just returning types that can implicitly convert between each other, then you can just use auto. And that was the case for when you have ints and doubles. All right, folks, I hope you enjoyed that video. That was just a little bit of a digression at the end to std.variant, but I think it's something that's useful. It's the same idea of, unions and other data and other programming languages like C and C++, if you're used to programming from that side of things. And I think it's just useful to understand, again, what's allowed in auto with what can be deduced. And D, again, tries to do things in a type-safe way as much as possible. But when you want to be able to truly return anything, you have some options like variant, VariantN, SumType, and some other things in the standard library that we'll get to. So with that said, folks, thank you as always for your time and attention. I'll look forward to seeing you in the discussions and in the next video.